All right, today we're going to talk about a piece of tech that's trying to fix one of the most annoying, frustrating parts of the internet. You know what I'm talking about? The broken link. This thing is called the Interplanetary File System, or IPFS, and it might just completely change how we think about where our data actually lives online. So let's just dive right in by talking about a problem that I guarantee every single person listening has faced. It's a fundamental flaw, really, in the way the entire web was first built. Of course you have. We all have. That dreaded, soul-crushing 404 not found page. It feels like you've just hit a digital brick wall. But here's the thing. That's not just some random glitch. Nope. It's a symptom of a much, much deeper issue with how the internet works today. Okay, so this is the absolute key. The web we use every day, it runs on something called location addressing. A URL, like example.com/cat.jpg, doesn't actually point to the picture of the cat itself. It points to a specific spot on a specific server where that picture is supposed to be. So what happens if that server goes down or the file gets moved? Poof, the link breaks. The whole system is just fragile. So how in the world do you fix a problem that's baked into the very fabric of the web? Well, IPFS comes along with this brilliantly simple, almost obvious idea. What if, instead of asking where a file is, we just asked for what the file is? And this comparison just lays it all out perfectly. The old way, you're pointing to a physical location. It's like a street address. But with IPFS, you're using content addressing. Every single file gets a unique, permanent fingerprint. You're not asking for the file at that specific house anymore. You're just asking for the file that has this exact fingerprint. And you don't care where it comes from, as long as it's the right one. Now, that sounds great in theory, right? But how does it actually work? I mean, how do you give every single file on the internet its very own unique and verifiable fingerprint? Let's break down that process. Okay, so IPFS takes any piece of data, a video, a document, literally anything, and first it chops it up into smaller chunks. Then, using some clever cryptography, it generates a unique hash for each one of those little chunks. Finally, it creates a root hash that represents the unique combination of all those chunks. And that final hash, that ultimate digital fingerprint, is called the content identifier, or CID. And this gives the CID two incredible superpowers. First, it's totally location independent because the address is literally derived from the content itself. And second, it's self-verifying. When you get the file, your computer can run the exact same hashing process. If the fingerprint it creates matches the CID you asked for, well, you know with 100% certainty that you have the right file and that nobody has tampered with it. It's like a built-in lie detector for your data. But a big pile of fingerprinted blocks isn't very useful by itself. We need a way to organize them. And for this, IPFS uses a system called Interplanetary Linked Data, or IPLD. Just think of it like the grammar of IPFS. It lets you link these content fingerprints together to create structures we all understand, like a folder that contains a bunch of different files. It creates this kind of family tree of data, where every single piece is linked and verifiable. Okay, so we have a unique, verifiable fingerprint for our file. Awesome. But now for the million-dollar question. If there are no central servers, how on earth do you find a file in a global network with millions of computers? The answer is a process called content routing. And honestly, the absolute best way to think about it is like a giant shared treasure map. This map doesn't hold the treasure itself, that's the file, but it holds all the clues about who has it and where you can go to find them. And IPFS has a whole toolkit for this treasure hunt. The main tool, the big global map, is something called a distributed hash table, or DHT. You can think of it as this massive shared address book. It's just a huge list spread across thousands of computers that connects a file's fingerprint to the network addresses of the people who have it. But IPFS is also really smart. It uses other tricks, like asking the computers it's already connected to first using BitSwap, or even finding a copy on your local Wi-Fi network with MDNs, which is, of course, incredibly fast. So the content routing system, our treasure map, has pointed us to a peer, or maybe even a dozen peers, who have the file blocks we want. Now, how do we actually get the data from them? This all happens using a protocol called BitSwap, and it's actually really simple. Your computer basically just shouts out a want list of the specific data blocks it's looking for. Other computers on the network, they're always listening, and if they have a block that you want, they send it right over. It's a true peer-to-peer exchange, a real marketplace for data, all driven by supply and demand. So let's just zoom out for a second. We've fingerprinted our data,
we've organized it, we've found it on a massive decentralized network, and we've transferred it peer-to-peer. What does it actually add up to? I think this quote from the official documentation just nails it. You can fetch data by what it is, not where it's stored. That is the fundamental shift. We're moving from a web of fragile locations to a web of verifiable content. It's such a simple idea, but it has these profound consequences.
So why does any of this matter? Well, first, resilience. As long as just one person on the entire network has a copy of a file, that link can never die. No more 404s. Second, verifiability. Because of those cryptographic fingerprints, you always know you're getting the authentic, untampered data. It also leads to amazing efficiency. You could download pieces of a huge file from 10 different people at once, instead of from one single slow server. And maybe the most important thing of all, it creates a path to a truly permanent web, a place where vital information, scientific data, and our cultural history can be archived and preserved for generations to come.
And that really brings us to the final thought here. This technology is about so much more than just fixing broken links. It opens up a whole new universe of possibilities. So I'll leave you with this question to think about. What could we build, what could we create on an internet where information is permanent, verifiable, and links never, ever die?